Hello, we're going to do Lab 8 today over Metamorphic Rocks. You're looking at Metamorphic Rocks. These are actually from New Zealand. Personally have collected these, and I can tell you there's just no place like New Zealand. That's not the only place you can find metamorphic rocks. They exist all over the world, but these have a lot of significance to my family because of how and where we found them and how rounded they were. You learned in sedimentary and depositional environments that rounding represents being transported. Well, rivers transported these from glacial melt in New Zealand and rounded them off and literally grinded them as they were being deposited along the shoreline of a beach. And it was just amazing because you could hear the grinding of these rocks as they were being tumbled by the shoreline waves. It was really quite remarkable. So you should have already done your metamorphic chapter reading and lecture videos. If you have not done that, you got to stop this lab and do it. Because you've got to have an understanding of what this stuff is before you start. And I need you to do that. And while you are thinking of it, I want you to turn to page 136 in your book and add a choice. It's in the instructions in bright space for the lab. It's serpentinite. You've added serpentinite, you've watched your lecture video, you read your chapter, it's time to do the lab. So you'll be taking out the Lab 8 metamorphic samples out of your rock box. If you do set them out all at once, which is not what I'm going to encourage for this lab because they look very similar, certainly take a picture before you do in case some seismic event happens and they scatter all over the room. Because they do look so close to each other and they can be mistaken for a different rock. For example, marble and quartzite can easily be mistaken for one versus the other. So, just like you've done before, you're a pro at it now. You just get your space all done. You get a nice, neat work area. I need you to test your samples using your streak plate, your hardness tools. If you got your acid, you can do that. That's kind of an interesting thing on metamorphic rocks. For example, marble, its parent rock, is one of two things. It can either be limestone or dolostone. So if there's still enough calcite left, it may react. Some of your samples will, so it's kind of cool. And you need to also make sure you have your lab page out in the choices that are on page 136 so you can refer back to them. Let's have a quick review of what foliated versus non-foliated texture means. So take a moment for looking at the different rocks thus far. You had igneous to start with, and they were either phaneritic or aphanitic. Phaneritic were the interlocking crystals. Aphanitic did not have that. They were the lava-based types of texture. So in sedimentary, you had detrital/clastic, which is fragments of other rock that get cemented and compacted together, and lithified, which means hardened. And then you had chemical/biochemical. And so we've been through all of that. Now we are looking at the third group of foliated versus non-foliated for metamorphic rocks. Let me be clear on something. You can't ever say that like a metamorphic rock, let's say it had foliated texture, you can't say that it has phaneritic texture for non-foliated or foliated. Subsequently, you can't say it has biochemical, chemical, or detrital/clastic. In other words, they are unique to that rock group. Igneous has its texture terms, sedimentary has its texture terms, and then, of course, metamorphic has its texture terms. So what's the difference between foliated and non-foliated? Quite simply, the arrangement of the crystals from metamorphic processes. So you have grade of metamorphism that you learned about in lecture, and the lower grades don't have as much heat and the key is and/or amounts of heat and pressure type situations going on. So the lower stuff doesn't have as much arrangement or changes in the crystal arrangement. But as you progress to intermediate and high, especially in the foliated arena, it goes from looking more like a mosaic or a piece of puzzle, like this is salt and pepper granite, and originally it would have phaneritic texture, but as those crystals get squashed by pressure and heated, changes in the rock occur, and a high-grade metamorphism, you can see from here to here, you get some banding, and that's what creates gneiss. So there's a series of stages of metamorphism between going from here to here. And that's going to dictate in the foliated texture which rock you're talking about. So it matters. And I might add, so do the minerals that get made during the metamorphic process. We'll get to that shortly. In non-foliated textures, it's not that you don't have pressure, but the real impactful change happens in the heat added to the rock. So this is a piece of quartzite right here, and the crystals are just in a hodgepodge arrangement. They haven't been smudged to create some type of a discernible parallel alignment of crystals like you would see in a foliated texture situation. You have a chart very similar to this in your book. And I want to point out that if you take the slate, for example, here's the slate, here's shale, and not all metamorphic rocks start with shale. This is just an example. But here's this little squiggly line, starts the lowest end of metamorphic for slate, and this one over here, which adjoins to phyllite, makes that difference. So if you kind of take your fingers and go up from both squiggly lines, it's going to end up on one side of the E and one side of the L for low grade. And the key is what minerals in between could be there, because that is what dictates how the rock will look. Quite frankly, as metamorphism occurs, so does the transformation of new minerals and changes to the rock. That's why they're unique and special. Same thing for phyllite to the base of schist. You take your fingers and go up. Now you can start to see you get a lot of biotite and muscovite and chlorite. That's why it's so shiny or has a metallic sheen. When you do schist to gneiss, you can see you take your hands and go up. You're more in the intermediate grade, and you just get lots of biotite, muscovite, which makes it very oftentimes metallic, shiny, flaky. You can get garnets. Lots of garnets are found in schist. Not that you can't find it in phyllite, you can. And you can find a handful potentially in gneiss, but most of them are in schist. And then you see in gneiss that things change, what you can have. Okay, so ultimately we get to a point past gneiss where we get melting. And then it would take us back to the igneous category. So that's what this whole thing means. These are the minerals, and you can see feldspar and quartz are present through all of them, but these are the minerals that alter during the metamorphic process, and these are the foliated metamorphic rocks that get made along the way. Grade is not just temperature, it's also pressure that gets applied. So get out sample 1, and I'm going to ask that you do exactly what we've been doing with all of these. You need to be testing them with your testing equipment. Then you need to pick them up and touch them. So when you look at sample 1, you're looking to determine if it seems to have a characteristic of foliation, where the crystals are starting to align in a discernible parallel fashion, which can often be seen as layering or flaking or kind of a roly-poly appearance or bands. But just because it may have a band or two, different non-foliated rocks can do that as well, because there's impurities in the stone. So be careful about that. So another cool thing is to try your vinegar/acid on all of these samples and see if there's a reaction, because if there is, then likely you're looking at a marble that has the parent rock of limestone, more than likely. And then you also need to be doing hardness, because that's a sure way to determine if you've got marble versus quartzite. These things are just part of the geology experience. So when you pick that sample up, you need to be testing to see, and I'm going to point you in the right direction. I don't see any evidence of foliation. In fact, I am certain it's non-foliated. I did the testing and discovered that I could scratch it with a nail. So what does that mean? Was it a low, moderate to intermediate, or high? Moderate to intermediate means the same thing. So in this particular case, I think this is a fairly low to moderate type of metamorphic rock. And you're like, well, how do you know that? Experience. And if you chop this open and could really look at the crystals, that would be the determining factor, because as more metamorphism occurs, more transformation and recrystallization happens in that process. All right, let's move on to sample 2. So you look at this sample. First thing I want you to do is thump it on the table. I mean, thump it, literally. All right, did you notice that some flaky stuff came off? And do you see that if you kind of touch this sample and you begin to pick at it, you could get some flakes to fall off? That's because it's foliated. So we have probably an intermediate grade. Notice how shiny this particular sample is. Notice that it's metallic. That's a very big clue. So we know it's foliated, it's flaky and metallic. So with your knowledge from watching lecture and reading this section, you should know what it is. So this is a moderate to an intermediate grade metamorphic rock that's foliated. What is it? Look at sample 3, pick it up. So you're free to break your sample apart in half, but when you do, you're gonna find, you can do it without doing this also. You can take your steel nail and you can try to scratch it, and good luck, because it's pretty durable. And its parent mineral has a higher hardness than your steel nail. So one of the key things that I find students want to say about metamorphic rocks, or sometimes especially this one, is an incorrect assessment of what the parent rock is. So you need to go back and look at various common parent rocks when it comes to these metamorphic rocks. And I'll give you a few examples. Slate is not always comes from shale. It can come from volcanic ash and volcanic lava. Marble's parent rock will always be limestone or dolostone. Quartzite always has a parent rock of quartz sandstone. Greenstone comes from a very specific type of groups of rocks. So when you look at that, and same thing with serpentinite, and obviously metaconglomerate comes from conglomerates. So, you got to kind of have that foundation in order to move into metamorphic rock. So when you see sample 3, the testing for hardness, I think, is really important. And then you could try to douse it with some acid and see if it has a reaction. I can tell you it didn't, but that doesn't rule out that it's marble, because as you start to get into a higher grade of marbles, you lose that calcite. And so that's not the determining factor. Really, how hard is it does. So I think you're looking at between a low to intermediate grade metamorphic situation for sample 3. It's not much more than that. All right, let's move to sample 4. One thing you should notice about right away is that it kind of has a similarity to a sedimentary rock that you have studied. It's undergone a low grade and always a low grade metamorphism. So it's a foliated metamorphic rock, which is the lowest grade of the bunch. And then that's exactly what you have here. As an FYI, this particular metamorphic rock can come in a variety of colors, not just the one that you have in your sample. Let's move to sample 5. All right, on sample 5, do all the testing. You're going to need to put the vinegar on it, /acid. You need to test for hardness, all of those things. And what I discovered was that it didn't react to acid, and it was pretty hard. So what do I think about the level of metamorphism here? Probably an intermediate. And you may wonder, well, how do you know that? Experience. And I also chop my samples in half. If you do that, please wear eye protection and understand that it's really hard to break some of these rocks open. I also have a rock saw. I didn't use it for these, but I do, and I could split them open and take a look and examine the insides, because that's where you really see how the crystals have transformed over time. All right, put that away and get out sample 6. Some things that stand out right away that's different about this one. You should see that the crystals look like they're in a parallel arrangement, making bands. Well, which foliated metamorphic rock is banded? And it's the only one that is, and that's what you've got. This represents a high-grade metamorphic situation. So take a look at it, examine it, and think about what its parent rock could have been. And that might help you with identifying that. So just about parent rock, really parent rock is a look at what we think it could have been. It might have been more than one. I mean, basically there could be more than one thing it could have been. So it just likely had an igneous rock as its parent rock. Can't be sure, but based on what I see here, likely the case. All right, let's get out sample 7. When you look at this particular sample, and I hope you have a hand lens because you can probably see crystals here. They're pretty small, but there's no parallel arrangement to them. So now you look at doing your hardness test, your acid test that might help you determine what it is, because I do not think this is more than a low to intermediate grade metamorphic rock. And I might point out that you're definitely and likely to have repeats of very common metamorphic rocks in this lab. So don't think there's too many of one kind. It's okay if there's 5 or 6 of the same kind, because these are the generic brands of the metamorphic rocks. There's some more complicated ones that are out there, but these are the ones that are in nature that you can find, some of them on a more regular basis than others. All right, let's move on to sample 8. So as you look at sample 8, and I'm going to get this one out, I want you to compare it to sample 7. And right away, can you see that the crystals are bigger? That's important because I think we're seeing a higher grade situation happen here where more crystallization occurred. So if you do the hardness test, you're going to notice that you still can scratch it with a nail. And it might react to acid. If it were a lower grade version, it probably would. That should tell you exactly what it is. But I wanted you to see the comparison, because as you're looking at these different non-foliated metamorphic rocks, 7 was a non-foliated metamorphic rock, and you lay it side by side with 8, and you can see that there's a real big difference between the two and how the crystals look. When you look at sample number 9, do the same thing. And you got to get it in the light or a hand lens on it. And you'll see that there's some fairly big crystals that look like they've been recrystallized. And same process. Test it with hardness, test it with acid. Since this is a higher grade metamorphic rock, if indeed it was marble, it may not react. The calcite could be gone. If it's quartzite, your nail won't scratch it. So that's kind of how you tell them apart. And since there's so much marble and quartzite in nature, this is one area where I feel like students might find the most of with metamorphic rocks. And I want you to have that experience so you can kind of see what it looks like. All right, let's get out sample 10. And as you look at sample 10, this is a great sample of it, by the way. You might go, well, I see the layering. It's got to be a foliated rock, and you're on the right track if you're saying that. But I want you to turn it over and start to see that there's a metallic sheen on it. And probably most of your samples have a slight, what I call roly-poly. It's no scientific term, it's just my term. But you'll see it in books where you will see this kind of wavy appearance. If you look at it, you'll see that. And the metallic is important. So if it has any metallic sheen to it in the foliated category, okay, that's going to knock out slate. So if it's phyllite or schist, which one could it be? So schist has a special property in the fact that it's very metallic and has lots of flaky crystals, because the crystals have been flattened from heat and pressure. So you're getting into the moderate to high metamorphic grade, where phyllite is low and sometimes to the intermediate. So I think you're still on a low area. You're working your way from just being plain Jane slate up to getting into the higher versions. So what rock would this be? That wasn't so bad, was it? But I'm making you do more on your own because I'm trying to get you to be more confident in your identification skills. You're not going to be perfect, but the more you do it, the better you get. That's just the way this works. All right, so I need you to pack up your metamorphic samples and come back in a few minutes, put it on pause, and then we'll move right into your pictures, which are the rest of the lab. Welcome back. It's time to get started on the rest of your lab. So I'm going to encourage you to go ahead and keep the list of samples that it could possibly be on 136 handy. And remember, you had to add serpentinite. That wasn't on the list. So we're going to go through this, and I'm not going to answer all the questions for you. I'm just going to guide you into trying to figure it out. So let's get started, and tell me what you see. Just think about it and even say it out loud to yourself. Do you feel like this looks like something you've seen before in sedimentary rocks? I bet you have, because I've certainly seen it. This is probably the most obvious of all the samples that you're going to get, besides gneiss that have bands in it, because you can see what looks to be clast of all various sizes, fairly large actually. This is a non-foliated rock. So if you look in your book, I was just looking before we got started, and you see on pages like 132 through 134, I have a list, different tables, table 8.3 and 8.4. give you guidance on what's foliated and non-foliated. I will say something about this one. If it underwent enough heat and pressure, then it could transcend into the foliated category, but it's not there yet. It's a totally non-foliated. This is a low-grade metamorphic version of this. So what do you have? Let's move on to sample 12. Wow, isn't that beautiful? First of all, metallic. You see the gold, those funny looking cube things here, these crystals and minerals. All right, pretty awesome. They're garnets. Now, what did I say about garnets earlier? What metamorphic rock do they most commonly occur in? Well, that's your answer. This is a foliated metamorphic rock. In fact, you can see the foliation. Do you see these little flakes right here? All over it. You can just see these flakes. Where there were crystals have been actually flattened and made a layering of these crystals, and these garnets grew within that. That's really special. That's why metamorphic rocks are some of the most interesting, to study because they have some really cool stuff in them. Likely the grade is intermediate to high on this. So if you were wondering where garnets come from, this is where they come from. So you find the rock, you find the garnets. Many are not gemstone quality, but some are. I have bags and bags of this stuff, and love it because, I don't know, I'm kind of protective of my garnets. I think they're really beautiful, and they're durable too. All right, this is one that is in your book, and if you look at the foliated list, this is it. And I want to point out that, it looks like a mosaic to me of crystals. Not really. Are you beginning to see in these sections where it's starting to make bands? So this can actually fall under the umbrella of a specific type of schist, but it has its own name. And I wanted you to see one of these, so it's actually in your choice bank. It is a foliated metamorphic rock, and it comes from mafic igneous rock, so it's the foliated version. The non-foliated version creates a different rock that actually has gem quality to it. So this is an intermediate to high grade metamorphic rock because it's starting to take those crystals and flatten them out. And you can really see it on the side here where it's starting to look and almost produce banding. It's not made banding, so it can't be nice. I don't see a metallic sheen. I don't see roly-poly, and I don't just see what looks to be like shale that's been slightly metamorphosed, which would be slate. So take a look at what this is, look at your list, your description, you'll know right away what it is. Sample 14. First of all, this is foliated. I want you to look at its color, its gold color, and then really look at this section in here. This is that roly-poly wavy stuff I'm talking about. It's distinctive in one foliated metamorphic rock. Which one is it? So this will have a low and sometimes to intermediate grade. This one's starting to be closer to the intermediate side, but not enough to produce flakiness. So that's obvious what rock that should be. All right, 15. So this is what pool tables are made out of, and dry erase boards and lab tables and so forth, and lots of flooring. And if you look at the right picture, that's the side look at this particular sample here. And it has a lot of similarities to shale. But it may not have been shale in its prior life. It could have been a volcanic ash. But you will notice that there's no roly-poly waviness to the top. There is no metallic sheen. So it's very low grade and always will be low grade foliated metamorphic rock. That's the giveaway right there. 16. When we look at 16, right away you see glittery. This is a silvery, glittery color. And these little things actually are indeed some garnets. They're not as beautiful as the last one you saw. But you can really see the flakiness of this particular sample. Even some of it has fallen off as I was photographing it. So you definitely have foliation, you have an intermediate to high, and this is always going to be this type of rock. And what makes it shiny is the mica and muscovite, biotite in it. That's what's happening in that temperature range. So if you go back to that chart for foliated rocks, the actual diagram, it's so obvious what this is. It's the only one that produces the flaky texture that has a special term for that. If I gave that to you to give the name of the rock away. So you've already seen several that look like this. All right, 17. This is a non-foliated rock. How do I know that? There's no banding whatsoever. In fact, this is stuff you'd find in a creek bed, lots of it. And when you see this, you just see a bunch of rock material. It almost looks like it's been soldered. But here's the deal. This is as close to the quartz sandstone as it was before it got metamorphosed. So it's a low-grade version of this. If it's been recrystallized, you start to see bigger crystals in here. It might even change color. So this is not, it has no bearing on the color. It's just the minerals that are in there that produces the color for this particular rock. It's non-foliated and its parent rock is always quartz sandstone. All right, this is one of my personal favorites. I have a Metamorphic Rocks. They're somewhat rare, but indicators of a very special type of metamorphic facies, which is like, oh gosh, that term is complicated. It basically means conditions in which certain rocks are found. So first thing I want you to do is notice there's no lacquer on this, by the way. That's naturally shiny like this. But look at this. All of this odd color, it's green. And the green is so important because it's peridot. So if you remember, peridot is olivine, and those form in ultramafic conditions most of the time. And this is definitely that kind of thing. This is an ultramafic rock that's been, that was intrusive, I might add, plutonic, that's been metamorphosed. And it turned into this beautiful rock. What is it? So it's a low to high grade version of what you're seeing here. But I think the giveaway is the ultramafic and it's non-foliated. All right, sample 19. How do I know this is foliated? I can see the crystals are aligned in a banded manner, and that's the key. So it's a high-grade metamorphic rock. It likely used to be salt and pepper granite in its prior lifetime before it got metamorphosed. And man, is that not beautiful. So if I had a choice and I was making my house out of countertops, like replacing my kitchen countertops, I would be making it out of stuff that look like this because I think it's so beautiful. All right, let's move into sample 20. What do you notice about the color right here? It's got green. Yep, that's a giveaway. You know, I see lines in it. Those are not bands. Those are impurities. So this is a non-foliated metamorphic rock. By the way, it doesn't just come in a green color. Depending on the impurities of it, may change it. It can come in a white, different shades of it. Matter of fact, I've been to New Zealand, and the Maori culture there, this is like a big part of their culture, is this particular stone. And they have different colors, so it's not just green. And they have lots of the cream colored, whitish color, different shades of it. And that's what this is. So it's a non-foliated metamorphic rock. It's a low to intermediate grade. And it came from mafic igneous rocks like basalts or gabbros. So this is what happens to those when they get metamorphosed. Oh, look at that one. You're like, wow, that's shiny. Well, it is, isn't it? This is such a great look. Do you see all these flakes here? There's only one foliated metamorphic rock that does this. And this is very classic for this type of metamorphic rock. So it's foliated. It probably came from slate or volcanic ash that went through the progression of being foliated as more heat and pressure was added. So this is an intermediate to high metamorphic rock. And when I say it makes flakes, it's the only one that does. And you've seen several examples of this in the lab. Sample 22. All right, its parent rock is quartz sandstone. That's a giveaway. So if I put acid on this thing, it wouldn't react. I wouldn't be able to scratch it with my nail. But the quartz sandstone parent rock, there's only one metamorphic rock that fits that bill, and that's what this is. So it will always be that way. You're like, well, it looks different from another one. Yeah, it does. And so this is probably been a bit recrystallized, so it's in the intermediate stage. And this is just another example. Very common metamorphic rock, non-foliated. Okay, 23. You tell me what's unique about this. Can you see it? Is it foliated or non-foliated? How do you discern which one it is? You're looking for characteristics. If it's foliated, does it have flakes, roly-poly, Doesn't have roly-poly, so it can't be phyllite. I don't see flakiness, but do you see any banding? If so, then it's nice. But let's move to the non-foliated. Do you see something that looks like no arrangement of parallel crystals? And the answer is no. I mean, you can discern that they are making some arrangement in a parallel fashion. So the parent rock of this used to be pink granite, more than likely. And it's been put under high-grade metamorphism to create this rock right here. What is it? 24. So you look at this thing and it really looks like it's a version of shale, right? Maybe some volcanic ash, but it's undergone low metamorphic conditions, and the layering at the bottom kind of gives you a good indication that it is a foliated metamorphic rock. And this is the lowest grade of the foliated metamorphic rock, so that's a breeze to figure out what that is. Sample 25. Wow, isn't that pretty? Well, let's take a look at it. It's non-foliated, and I can look at that and see, because you can see there's no parallel arrangement, no wavy or roly-poly, no layering, no flakiness, no banding. Instead, you look like you have recrystallized minerals all throughout this, fairly large, I might add. This indicates that this sample has undergone a high amount of metamorphic, especially heat changes. So its parent rock is quartz sandstone. There's only one rock that fits that requirement, and that's what this is. That wasn't so hard, was it? All of these, you're like, hey, it's just a lot of the same stuff. Exactly. So that's the whole point of this lab, is exactly. You are starting to learn to look for certain characteristics in each rock type. A basic fundamental background in minerals helps you do that. And then now that you've been through all three rock types, you have a better feel as to, okay, I know some differences between igneous, sedimentary, metamorphic, and you may embrace a favorite of each type and have your ultimate favorite rock of all time. But the idea is that you can get out and start seeing more and have a knowledge that empowers you to understand the world around you. So here is my Metamorphic Rock Lab clue. These lights come from the Middle East, and they were given to me as a gift. I am absolutely passionate about them. I find them to be very beautiful. They give me a lot of joy. I love the design and find this to be extremely beautiful, kind of how I feel about metamorphic rocks. And so if you were to ask me questions about this lab, I would want to know where they came from, when I got it, how I got it, and the order of the colors of the bulbs, that kind of thing. So I know that we're on the same page. Having said that, I want to say I'm proud of you. You guys have just done excellent work. And usually the identification labs tend to be the hardest part of these courses, and these videos are designed to help minimize that. And I think you found that to be true. We still have one more of these to do. That doesn't mean you're done with lab for the semester. It simply means you're done with the identification labs once we finish fossils. See you at the next one. Bye.